My screen visible to all of you?
Yeah, ma'am, it's still not. It's coming. Yes. Yes, madam. Now it's done. There.
So here in today's class, today's outlines are we will discuss the basic concept of compiler. And as I told you that depending on the task in different phases of the compiler, we will decide that whichever phases belong to front end and whichever phases belong to back end, and some other things also which I have already discussed yesterday verbally, that also we will clear today. So what is our aim with this course? That we want to learn the techniques that how our modern compiler works. And the textbooks already I have told you that Aho, Ullman and Shetty. The whole name is written here. Aho, Ullman, Shetty is your main textbooks which you can refer from your library or from ebook as well. And other books also are welcome. Not really. Okay, so basically we will cover the phases of compiler. Before going to that part, I just wanted to show you what I have discussed last day. So we have discussed that compiler and interpreter, how it works. It scans the whole code at one go, and after scanning, if you have written anything errorless, then it shows you the errors line by line with details. But if you have not written any error in your code, then its output will be to generate a target code. Now, target code can be a low-level language. Sometimes it can be a assembly level language as well. But anyway, it will act as a translator that will translate from a source language to a destination language. Okay. Now, different types of translator already I have told you that interpreter, compiler, assembler. So depending on the source level language and target level language, you will choose that which type of translator you need. Either you need from high level to low level, then you will go for either interpreter or you can go for your compiler. And if you need from assembly level to machine level language, in that case you can opt for a translator which is called assembler also, which I think you have already learned in your microprocessor. That assembler you have used. Now, have you uh, have you had a subject called microprocessor in this fourth
No,
semester?
madam.
No. Okay. So
No,
then you have
no,
not
madam.
used that. But let me tell you, with the old syllabus, they had a subject called microprocessor. There they used to use this assembly level language, where this assembler or translator, using that they used to write the assembly level code in their labs. Okay. So anyway, and also we have discussed last day that the main difference between compiler and interpreter is that the interpreter translates, both are translator, they both translate from high level to low level, but the way they translate is little different. They one checks the whole code at one go, at one shot, and other checks it's line by line. Okay. So that is why I have asked you that which will take more time and which will take less time. So you won't have answered to that. We will not go to that part. Okay. Now, in today's compiler phases, first let me show you that what are the phases actually are there in your compiler design. Okay. So there are basically these 7 phases. Okay. First phase is known as lexical analysis. Second phase is known as syntax analysis. As of now, just look at the PPT. I know you will not remember these phases, but I will just mention these phases when I will discuss the whole chapter. Okay. Just as of now, just try to remember the first phase is lexical analysis. Second phase is syntax analysis. Third phase is semantic analysis, where the syntax related translation takes place. Fourth phase is intermediate code generation. Fifth phase is runtime environment. Sixth phase is code generation. And at last, if you need any kind of optimization in your code, then this machine independent optimization techniques are also applied. Okay. And if your optimization is not necessary, then up to code generation only, you can complete your whole compiling process. Okay. So, when we are studying about these phases, first of all, we should understand that this compiler design, is it an old discipline or it's just a growth or a new one? So let me tell you, yes, this is an old discipline because already C is coming from the 1972 onwards. So we all know that this is compiler designing is going on before that. So obviously it's not a new discipline. So it is a well established discipline where for designing any compiler, what are the algorithms popular, what are the methods, what are the techniques to develop the backend of the compiler, or how that growth of these stages can be done, or the merging of the stages can be done, that also they have explored. So the growths are not new. Okay, it is already developed, and in modern compiler we are trying to do this automatically, or we are trying to do some modernization on top of this established system. Then the question may arise in your mind, automation is possible. So for that, why then again we have to learn this well-established system? We all have used already in C. We are using right now Java. So there also we are using compiler. So why we should learn this? So basically, in this subject, it is not to learn how to use the compiler, but there are many tasks which needs the concept how this compiler works at the back end. Like when you cannot develop this whole compiler in your project, but in some of the project case, like if you want to validate your forms which you are creating for your project, or if you are working for some scripting, or you're creating a simple interpreter. So in that case, you can utilize this concept of compiler designing. So compiler is nothing but a translator, as I told. So in one go, it tries to translate from a source language to destination language, whereas interpreter, it is also a translator, but it involves the checking of line by line. So it executes one line at a time. If it gets any error, it holds there, and unless until you are rectifying that, it will not go ahead with the rest of the lines checking. So this is the main difference which we have already discussed. Okay, now, what are the uh, background knowledge you require if you want to understand this compiler design? You have to have an understanding of algorithm, because when you are writing an interpreter or you are developing an interpreter, so you will have the algorithms to detect the tokens, to write the rules, to match the grammars, to create the syntaxes, to check the semantics and everything. Okay, so you need a knowledge how to develop an algorithm. You also need knowledge about automata, because you are dealing with the or you are making an what kind of, I should say, it's an interface between your hardware and your software. So you are developing such a software which is actually taking help of your hardware resources, and also it is following the instruction given by the user. So definitely you should have a common understanding about both the things, that how what is the architecture of your machine, and what instruction is coming from the user, and depending on the instruction coming, how I will allocate my resources, how I will utilize my resources, and utilizing those resources, how I will save those data, how I will access those data, what methods are suitable, and so on so forth. And accordingly, if your compiler is platform dependent, so it also has an role for your operating system also. So you need little bit knowledge about operating system as well. And apart from that, if you are writing that grammar rules and checking the grammar rules of that particular programming language, so you should have a knowledge about your automata, which is your theory of machine. That knowledge also will be required. So these disciplines are mainly involved while you are trying to develop some interpreter of your own. or you are trying to work on this field. So basically, this is an abstract diagram where it is taking input your source language or source code, and it can generate two different outputs. In a ideal case, it will generate a target language, which can be machine code or any other level language or target level language. And in the bad case, that means we have not written the correct code, not according to the syntax of the programming language. In that case, it will generate an output of errors. So a bunch of errors if you have written many lines, errorless lines. So this is the abstract diagram of your compiler. Now, so what we do in our previous slide, the green module is showing a single box where this each of these 7 phases, which I have just shown you in the BPT, those 7 phases are involved. Okay, where the inputs are coming from the left hand, and it is generating the output at the right hand after traversing these 7 phases. But what we do, we developers, what we do, we divide these 7 phases into two different parts. Why we divide these two phases, two modules? Because some of the phases out of these 7 phases, we have seen that some of the phases are just understanding the source language. Understanding means here we are talking about a translator. So the translator will first need to understand what the source language is. That means what the source language is, what is the syntax or what is the semantics which are allowed in that source language. मतलब मेरे बोलने का मतलब ये है कि एक ट्रांसलेटर को ट्रांसलेट करने से पहले उसे ये जानना जरूरी होता है कि यूजर ने उस कंपाइलर में जो सोर्स कोड लिखा है वो सोर्स कोड कौन सा है. This may be C, this may be Java, C++, Python, anything. तो जो भी कंपाइलर के पास एज ए इनपुट आएगा, सो उसे फ्रंट एंड में पहले ये टोटल जानने की जरूरत है कि सोर्स लैंग्वेज क्या है. अगर सोर्स लैंग्वेज सी है तो उसके सिंटैक्स सिमेंटिक्स कुछ अलग होंगे, ग्रामर रूल्स अलग होंगे. अगर वो C++ है तो वो अलग होंगे, बिकॉज बोथ आर डिफरेंट टाइप्स ऑफ लैंग्वेज. वन इज प्रोसीड्यूर ओरिएंटेड, अनदर इज object oriented. So both functionality and both semantics and syntaxes will not be the same. At least little bit difference will be there. Okay. So that means in your front end module, the green part at the left, in your front end module, basically you are trying to understand that what is the source code is all about. If it is X source code or X language, then how should we proceed, and what is its allowed rules, what is its allowed syntaxes, what is its allowed semantics, whichever user has written, is it according to the source code's syntax and semantics or not? So it needs to understand about the source code, whatever user has written in the source language. Okay. Now, the back end, which is at the right hand side green box, you can see they are actually, after scanning the whole source code, after understanding the rules and semantics of the source code, now it's time to translate to the target code. So there comes your actually conversion. Okay. So from source code to machine code, the conversion actually starts at the back end. Okay. And between this front end and back end, there is one intermediator, which is known as intermediate code. So that comes as a IR. Okay. So this is basically a type of interfacing is done between these two parts, front end and back end. And how this front end will be mapped to back end, that will be decided by your intermediate code, whichever you have represented. Okay. So that is why in your front end, there are multiple phases involved out of those 7 phases, which I have just discussed. And your back end also, there are multiple phases involved, where actually your translation or conversion starts. And at the last of this back end, either you generate your machine code to write the whole lines of code in your source code correctly, then it will generate the proper object code for you. And if it is not, then definitely it will generate that bunch of error lines. And whichever lines you have written erroneously, that will be written there in detail. Okay. Whether I started the recording or not. Let me start that. Okay, so up to this part, anybody is having any doubt? Anyone is having any doubt?
No, madam.
No, ma'am. No, ma'am.
Many people are there, but only answering is being given by few. So is it the case for all of you? Have you understood up to this part? See, these are theory things, so it may look boring to you right now, but if you will not understand that what is the purpose, why I am telling this, then you will not understand that why it is needed, why this explanation is needed. Because if I tell you right now to write a rule for this, you will not be able to do that. Okay. So you have to understand the basic things. Though it looks boring for you, it just looks theoretical things for you. But these are very basic things which will help you in my future lectures. Okay. So right now we are trying to divide the whole part of our compiler designing phase into two different segments. One is front end, where we are trying to understand the rules, the syntaxes, the semantics of our source code, and then we are trying to go back, go to the from front end to back end for actual translation or actual conversion. Okay, so in between these two, one
Hello, ma'am.
matter is there. Yes.
Ma'am, what is the meaning of legal code here? First
Okay.
one, content. Hello.
What is the meaning?
Legal code, ma'am. Content maps legal code into IR. What is the meaning of legal code?
I'm not getting your query.
Can't understand, ma'am.
Can you come again?
Ma'am, he's telling that front end maps legal code into IR. So he's not able to understand what is the meaning of legal code.
Legal code. Okay. And now I can see. Front end maps legal code to IR means legal means which code you have written. Is it according to the source language syntax or not? Means suppose you are writing a code in C. So C is having certain rules, some syntaxes you follow while writing your C program, but it may not be suitable in your Java because Java is having some other set of syntaxes which is not available in C. So I'm just talking a generalized term. Generalized term means I'm talking about a compiler which can be suitable for Java, can be suitable for C compiler, can be suitable for C++ compiler. So in a general term, the legal code means that code should be according to the syntax and semantics of that particular source language. বুঝেছো? লিগাল মানে ওই যে সোর্স ল্যাঙ্গুয়েজে তুমি লিখছো সেই সোর্স ল্যাঙ্গুয়েজের যা সেট অফ রুলস আছে, যা সিনট্যাক্সেস আছে, সেইটা ফলো করে যদি কোডটা লেখা হয় সেটাকে আমি টার্ম দিচ্ছি লিগাল কোড। মানে ইট ইজ নট ইললিগাল। Understood? Who was asking a question? Pratik, বুঝেছো?
Yes, ma'am. Ma'am, reply each okay, ma'am. That
হ্যাঁ,
helps.
madam.
Oh God, I would have to check the chat box as well. Chat box কাল খোলা রাখতে হবে। বুঝতে পেরেছো প্রতীক?
হ্যাঁ, madam.
Anybody is having any other doubt? Acha, IR. Yes, IR. IR is a mapper. Mapper means from front end to back end, you are going forward towards the phases. What you are doing, your source language is different, and your translator is going to represent it in some other language, which you are taking as a machine code or target language. ঠিক আছে? Just wait for a second. Let me charge my system.
Right.